All right, good afternoon. My name is Brian Blumhagen. I work for a company called Altenburg Construction. We are a slat replacement business, so the only things we do really are from the slat down to the bottom of the pit. We are about a 30-year-old business located, headquartered in southern Minnesota, South Central, just north of Fairmont. We do have a central Iowa location there, east of Ames in a little town called Zeering. I actually live out of the Ames area. And incidentally, we're just bought a property down here in the Washington area, and we think we'll probably be developing that over the next few years and having a location down here as well. But what I want to talk about today is keeping your facilities safe and functional. Incidentally, my background, I grew up on a cattle and hog farm in Northeast Iowa, got my undergrad and graduate degrees at Iowa State. First 24 years in the pig industry, I worked for PIC selling genetics, and then had the opportunity to move back to Iowa in 2017 and spent the next 7 years doing new construction maintenance and nutrient management for a large producer here in the state of Iowa, and have been with Altenburg the last couple years. So what I want to talk about today more specifically is kind of setting the table, the aging infrastructure we have as a swine industry and what's coming at us in terms of, capital improvements and injection into capital to keep this infrastructure going. And then we'll talk about inspecting your barns, what to pay attention to, and all kind of the major components. And then I'll finish up by talking about what these sorts of repairs are going to cost to give you guys kind of an idea what the investment you're looking at there. And again, feel free to stop me and raise your hand if you got a question. A lot of pictures in here, so if there's something you see you don't understand, let me know. So last winter, we were talking in our business, trying to understand what is the amount of work that's coming at this industry. And so what I've done here is I took the hog and pig report from last December by state, and I backed into the numbers there. And so I've made some assumptions here. So on the left-hand column, that's the number of market hogs per year in each state. And I made some assumptions. I backed into it and said, we're going to run roughly 2 turns through all these facilities. And then I made a further assumption that those pigs are residing in either a 1,200 head room or a 1,200 head barn. Okay. And then kind of the last assumption I made was, let's say that the components on these barns roughly have a 30-year life. And you can argue curtains aren't going to make it that long, but certainly the slats and the pit and the trusses and those sorts of things should. So what the math says is, for example, in the state of Iowa, they're the top one. And I just did Iowa, the states that border Iowa, and I layered in Indiana, Ohio, Michigan, and Kansas in addition to that. But for example, in Iowa, we have 668 of those 1,200 head equivalent barns that are aging out every year. And kind of the other high level assumption I made was we really started building these confinement facilities in earnest in the late 80s, early 90s. So that's really when the boom got going. And so those barns that we built back in 1990 turned 35 years old this year. Okay. And so every year there's another 668 barns in Iowa we added. Okay. So total there is 1,533 barns. There's just under 46,000, across the pig belt, if you will, that are getting older every day. Okay. And then just the reality of new construction. So I helped build a lot of barns from 2017 to just before COVID. And, our typical 2,400 double wide tunnel vent barn, when I was doing them through 2017, 18, 19, we were getting them built for $285 a pig space, all in, turnkey. That was land, site, well, everything. When we got towards the end of that period, there was probably up and around that $325 a pig space to build that double wide finisher, and then COVID hit, and we all know the realities of what inflation has done since then. The reality is today that same barn in Iowa is going to probably run you at least $425 a pig space, and in Minnesota it's going to be $450 to $500 a pig space. The other harsh reality is we were financing those starting with a 4 or 5 digit number on the mortgages, and today it's a 7 or an 8 on that mortgage. So you add all that up, and a lot of these barns are going to have to be financed up to 20 years just to make them cash flow. And for the older people in the room, you can remember in the 90s, we were building these things for $120, $150 a pig space, financing them over 5 to 7 years. And it was a great equity builder. But when you have those kind of numbers, you're going to have to probably get at least a $50 bill just to service the debt. And there's not a lot of people that want to sign up for 20 years and just servicing debt. And really the only upside from an economic standpoint is the manure in capturing that. So the question I'll start off with, and we'll circle back to this at the end, is how many of these do you think we're going to build under the current economics that we're seeing in the industry? So we'll move into now inspecting your barns, what to look for. We'll start off with the roof and the truss system. And I would say if you have a barn that's, at least 20 years old, I would suggest you get in there once a year and look at that attic and see what's going on there. I recommend to do it in October for 2 reasons. One, it's the most pleasant time to be in an attic. Pick a really bright day. And the other reason I say October is it's before snow season. So if you do have a weakness in that barn, what's going to expose it is that, early December, heavy wet snow, or right now in March, where you get those really heavy ones and load up that roof. If your truss plates are compromised, that's when it'll this lower right picture here, you'll walk in the barn that morning and that's what it's going to look like. Hopefully it happens when you're not in the barn, certainly. But what you really want to pay attention to are all these truss plates. That's probably the number one item to look for. I mean, if you climb in your attic and you can see this, you don't really have to go any further. Just call your contractor and figure out a plan. But these plates are galvanized, and there was eras where the industry probably went on the cheap, if we're really being honest, from a galvanization standpoint. And the higher the G rating on a plate, the more resistant it is to corrosion. It's just the more zinc that's in that plate. And that's what you want to look at and tap on it with a hammer. If it disintegrates, you got a problem. It's not going to hold the way it's supposed to. And you can see that in this picture here. Those plates at the peak there have all let loose. So that's what you really want to look at. The other thing to pay attention to would kind of be your nail patterns. If you see a lot of missed nail patterns, you probably didn't get the best framing install in the world, and that's all designed to work a certain way. There's supposed to be a certain number of nails, a certain type of nail, and a certain pattern all throughout that webbing and that truss system. The last thing to look at is just your insulation. A lot of these barns are insulated with cellulose, and over time it just compresses and compresses and compresses, and you lose R value. So that might be something. The other thing is prevailing winds. If you get a really strong wind, it'll probably move that insulation around, and that might create some cold spots and some dripping down in your rooms. If you notice that, it's probably because there's no insulation in that particular spot. Another thing to look at on the outside of the barn, very few people do this, but any barn that was built after 1998 should have a perimeter tile within, if it's a deep pit barn, should have a perimeter tile within 4 foot of the footer of that pit. And we can do one of 3 things with that perimeter tile. We can daylight it if it's on site. We can sump it out if we don't have the right grade. Or you can hook to a tile line. The last 2, you have to have a gate valve on it. Or the last one, you have to have a gate valve on it. And the whole purpose of that is to get the water pressure off of the base of that building. And when that's really important is when you're pumping your manure in the spring or fall. Worst case scenario, let's say that you had it hooked to a tile line and it got crushed for whatever reason. So now that water can't escape. If you pump that pit down and say you only got 18 inches left and we happen to get one of those 2 or 3 inch rains and it just, all that water comes at that base of that building, it will heave a floor up. That's what these guys here they're a bunch of 5'7" guys flat handing the ceiling. That floor would come up, almost 12 inches. And that's at the point, the slats are going to start dropping in there. And that's actually what happened down here in this picture. So it's just something to be aware of. They're designed to get the water pressure away from the base of those barns, and we just call that heaving. The other thing, the single most neglected item in every pig farm in the U.S. is, fans and pit covers. If you happen to be the 1% that actually washes them and makes sure that they're sealed up, congratulations. But there's a lot of room for opportunity in a lot of these systems to really focus on those and get them cleaned up and sealed tight and functioning the way they're supposed to. Bulk bins, pretty much bulletproof from what I've seen. If we didn't put them in front of an exhaust fan and blow barn gases on them all day long, and if they were, put on a pad with a good footer underneath them, they'll last forever. You obviously will have to replace boots from time to time, but for the most part, they should be pretty well bulletproof. And then curtains, it's all about rodents, power washers, and adjustments. If you can keep the rodents and the power washers away from them and keep them in adjustment, you should get, at least 7 to as much as 10 years out of those. As we move inside the barn, probably the number one item, we spend a lot of time inspecting barns. The number one item I see that really gets neglected is this sill plate. There should be an anchor point there every so many feet. And in the earlier barns, this is a 2-foot stem wall. And the pigs, when we designed these barns, were only 240 pounds, but today they're 320. So they're peeing and pooping in that sill plate. Those early anchors weren't necessarily galvanized or stainless steel, and so they just, will rot off. I saw during the drate show several instances, straight line winds where it literally just shifts it right off that stem wall. It's really cheap and easy to repair. It doesn't take much, particularly when you have your hog paneling off, to re-anchor that down. And it is a pretty critical component to keeping that barn attached when you have either straight line winds or tornado, sort of situations. The rest of it, gas lines. The only thing I would say there is there was an error where we used those flexible stainless steel lines from the main coming into the heaters. If a barn does get struck by lightning, they have a tendency to explode. And a lot of insurance companies, I know in some cases, have mandated guys getting those out of their barns. Gating, it's really about just keeping stuff tight, particularly the wall brackets. If you keep it tight every turn and keep that movement from happening, you can extend, the life of that gate. The other part is just keeping those foot pads tight and not deteriorating your slats, because if they start banging on those, you can create some problems. And we'll talk about that here in a few minutes. Plumbing, electrical, the big thing on electrical is just keeping the panels closed and keeping the moisture out of it, Inevitably, it's going to get corrosion in there and have to be replaced. But inside, the only other thing is, the first piece of steel in almost every barn is this knee brace here, followed quickly by the steel right around the inlets. And it's just because that's where that cold, hot air transfer is, and we get condensation. And those are the parts that are going to rot out first. All right, moving into the pit side of it. Again, our business is all about, we inspect barns, we do these emergency, responses and what we call service calls, and then we do the full slat and beam replacements. Our goal is to try and prevent these as much as possible. And that's a lot of what I'm here today, is just to educate people. It's one of those things that you walk on it all day long, and most people don't understand how it works and kind of how critical it is. And as we age these barns, it's becoming a bigger and more timely topic, if you will. So from a high level, what we see is these barns, if it was a good slat manufacturer and it was a good install, you should be able to get a minimum of 25, probably on the high end as much as 35 years on a finisher slat and beam package. We've seen extreme cases that'll make it as much as 40, but and on the low end, when you have a bad quality product or install, we do replacements as early as 17 years. That's kind of the big picture. A south arm will typically make it another 5 years on top of what a wean to finish type setting would be. But if you do happen to come into your barn someday, and hopefully you're not in it when this happens, you know, call us. We can fix that. That's something like that would take us probably a day to get put back together. And I'll talk about, this is the number one failure. Well, yeah, it's the number one failure we see, and it's also the number one service call, is these beam pockets here. And I have some better pictures here, and that's what happened here. The beam walked out of the pocket and it collapsed. Those beams are carrying about 10,000 pounds each when you get 300 pound pigs in that pen. So that's kind of the weight it's carrying. Inspecting the barn, obviously, you know, call someone that's qualified to do it. Don't ever go in the pit. You know, hopefully everybody in the industry knows that by now. But we spend all our time when we're doing an inspection is focusing on the surface bearing, these beams and this column. The slats are really easy and obvious. If the slat's going bad, just about everybody's going to see that. But what we're really concerned about and focus on is what's the surface bearing of these beams on this column, and what's the quality of the column and the beams. Not that the slats aren't important, but the big massive failures don't happen because of an individual slat. It's usually a beam or a column related thing. So a little bit about how the concrete system works. You know, these are structural. They keep the walls from the pit from collapsing in from that pressure we talked about. But these things are made out of concrete and steel, and so they kind of offset each other. What concrete's really good at is compression strength. So it resists getting crushed really well. The other thing that concrete's really good at is resisting corrosion. Okay. What the steel does is it does what concrete's weak at, which is tension strength. So concrete, if you didn't have any steel in it, you get a big long beam, you could just snap it in half because it can't take tension. And so inside these beams, like up here, there's 2 strings of rebar at the top and 2 at the bottom. This one is a bottom side view of a beam, and you can see that rebar running the length. And so steel is really good at tension strength and that, but what it's really terrible at is corrosion. It rusts really easily. When steel rusts, it expands and it'll blow that concrete apart. So that's the whole name of the game when it comes to the slats and beams. It's how long can I keep my slats and beams from that rebar getting exposed? Because the second the rebar is exposed to those gases and acidic liquids and all that, the clock's ticking. There isn't an additive you can put on there that anybody's ever made that's going to slow that down at that point. Okay, so that's what we're looking at. What we need to inspect a barn is we need it clean, dark, dry, and empty. So we do everything from above with flashlights. It takes about 40 minutes for us to do a 1,200 head room. And the way these beams deteriorate, and I got a few pictures here, so bear with me, is generally the first crack is on top of the column because that's where all the load is, okay? And as it ages and it deteriorates, it moves. So it'll start right here, and in a bad case, you'll get a crack on your column in 2, and that's where we get the beam drops. So they both shear is what we call that. And so once that crack starts, now it's into the rebar. And what it'll do is it'll chase all the way across that beam like you see here. Okay. And that's really the time period. And it's highly variable from what we see. You know, some manufacturers, that crack can take 5 years to move from here and start getting out in. And the more that we see this crack, that's the more concerned we are. And that's going to determine whether you have a slat and beam replacement in 3 years or 5 years or 7 years. Okay. Another thing I want to point out here is, I said earlier, it's all about the quality of the manufacturing, the slat and beam, and also the install. They both are equally important. So this picture here, great quality beam, terrible install. We want that 50-50. This beam's sitting about 90% of its face on the column, and this one over here is 10. It doesn't matter how well the beam was manufactured, it's going to fail quicker, okay? Conversely, this picture here, perfect install, 50-50 on the column, but a bad beam for whatever reason. Maybe it was Friday afternoon and everybody wanted to get home. I don't know. But they both are important. And what we're looking at when we're looking down through that slat is, here's an example. I can see that cracking starting, and then I'll jump over to the next rail and I'll say, okay, is it leaving the column? A worst case scenario, it starts, the rebar literally falls out of the bottom of the beams. And something like that, the slat should have been replaced long before that. That's a real risk. Okay. Moving on to the slats. Again, it's easy and obvious. When you start seeing, these cracks on the surface of the rail, if you look to the bottom side, that concrete's blown apart, and that's what you'll see. And it's starting to lose all that tension strength. The ones the engineers really get scared about, that can be a really fast failure, like these sorts of things generally happen over long periods of time. But if you get where you have a significant crack across every rail on an individual slat, that can literally just shear off. Because again, surface bearing matters. This is what's getting set on the edge of the beam. And that rebar is sitting in about an inch from the edge. So if you got poor surface bearing there and you get a crack, that's going to shear and drop. And kind of the last part I want to talk about is these beam pockets and some stuff to be aware of and look for. So in the early days, the common design in these deep pits was we slid these beams into these beam pockets on the end wall, and then they sat on the center wall. And it's just a bad design. Nowadays, we just pour a column there as an industry and capture that load. But if it didn't get tucked in there all the way, or if you get that shearing on the edge, and in combination, there's a gap between these two, so this beam can actually shift. It'll actually walk its way out of that beam pocket. And it's typically on your walkway one where you load out hogs, because it's getting all that moving and shifting. Okay. So what it'll look like in the barn, if it doesn't drop in, is you'll get these edges. We call those toe kickers. Okay. So take home message here is, if you're choring a barn and you start tripping over something you've never tripped over before, that's your barn whispering to you, get out, do something different, because something is shifting and moving. The other thing you may get is a rocking slat. Doesn't mean it's just as severe as this. It might have just lost a shim. So when we install these, we put plastic shims, because not everything's perfect, to take the rock out. So maybe a shim fell out. But the point is, if you're tripping, or you have employees tripping where they haven't tripped before, that's a problem. You should call somebody to have that looked at. Just another example of what it's about a 4-inch gap right here that wasn't there. And again, another example of really poor install. All right, so I'll move on to the last part, and we'll just talk about these barn repairs, from a high level, what's it going to cost. So this would be an all-in labor and material sort of number. And I tried to put it on a per pig basis based on a 2,400 head type facility. So if it's bigger or smaller facility, it's going to be adjusted. And these are just ballparks. But if you were to put a new roof on, like 29 gauge G100 steel, a re-roof is going to cost about 20 bucks a pig space. Incidentally, we talked all about the truss plates. It is a repairable item, okay? And the best time to repair truss plates is when you have the roof off. If you have to go in there and do it while the roof's on, the contractors are going to tear up your insulation. You're going to have to redo that too, and it's really expensive to do it. It's much more expensive to do it inside an attic than when the roof's opened up, okay? But most truss manufacturers will actually have a print design that'll show how to plate those truss plates. And some, like even EPS, will actually pre-cut the plywood for you, and they'll give you the nail pattern that's supposed to be done. So it's a repairable item. If you have to do every truss plate, it's going to be a lot. You can get by with just doing a few. Obviously, it's going to cost less money. Slat and beam replacement, you're looking at $60 to $75 a pig space. A big variable in that is how far are you from the slat manufacturer, because we're talking about lots of semi-loads of really heavy stuff in and out of the site. The other variable is In the early days, the way they built these barns, they poured the pit, set the slats, and then they poured that 2-foot stem wall on top. If that was poured on top of the slats, we have to cut that out, and that's an extra step, and that would put it closer to the higher range there. Slat shield, just incidentally, it's a product we offer. Something I didn't say earlier is wet dry feeders will cause the slats underneath them will age at about twice the rate of the rest of the barn. So if you've got a wet dry feeder and you don't have any sort of protectant on those rails around there, you won't make it to the 25 or 35 years. That slat will have to be replaced beforehand. It's just a really caustic environment. The feeder run generally, even on a dry feeder, will wear out quicker, but it's really severe on a wet dry feeder. So we do offer a product. There's several good ones out there. That's what the blue patches are. Ours is a polymer, a 3-part polymer, and we coat those rails around there to protect them so that they age with the rest of the barn slats. Sealing, a few different options here. A lot of steel ones out there. Unfortunately, you can't put steel or aluminum over steel, so that's really not an option unless you're going to tear down the steel, which then means you get to re-insulate. So quite a bit more for that. You can put plastic over existing steel, so a little bit of a savings there that you can have. Gating, this is a ballpark. There's a lot of different gating packages out there, depending on, if you have a fast alley or your short alley or some of those sorts of things, but kind of a ballpark number would be in that $35 a pig space. Yeah, and there's a lot of options from stainless steel foot pads and T-posts and those sorts of things, but that's kind of a ballpark number. Feeders, $11.50 a space for dry type, or $17.50 a space for a wet dry type feeder. Curtain replacements, again, they charge us by the linear feet, but roughly $6 a space to put a new curtain on a building. And then the last one down there, insulation. If you were to reblow the insulation in, probably looking at $6 to $7 a pig space for that. So kind of to bring it all back, new construction, $425 to $450 a pig space. Remodel everything but the trusses and the pit, something less than $250. We actually did this last year. There was a site up near our office in southern Minnesota that had been in bankruptcy for several years. Didn't have pigs in it for 5 years. It was a 4,000 head, 2-barn, 4-room site. We took it down to literally the studs. We took and the roof was collapsing. We plated every truss. We re-insulated, re-steeled everything. Like I said, the only thing we didn't, we left the studs and the trusses. We did plate all the trusses. We drilled a well. We made a connecting hallway, dock high load chute, all new plumbing, all new electrical, all new gates, feed systems. We added 4 bulk bins and relocated them all. Anyway, long story short, we were into that for less than $250 a pig space. So kind of the good news is, I don't know that we planned this 30 years ago, but for the most part, all these parts and pieces on these barns are replaceable. And I think the current economics say that's what we're going to be doing for a while. So with that, the last thing I would leave you with, if you are in the market to be purchasing a barn, please get the slats and beams inspected before you make that investment, because we've had several cases where young guys have bought barns and then all of a sudden found out they had to replace their slats and beams and they weren't expecting it. So that'll entertain any questions. Oh, all right. There's my contact information. If you have a question, give me a call on my cell phone. Incidentally, we did invest in a crusher this last fall. If you do have something bad happen to one of your sites and you need to make it go away, we can help you with that as well. So.